ligands. And that day I had told you that ligands are the molecules or the ions which bound to the central metal atom or ion. And classification of ligands, we have seen, we have done. Classification of ligands depends upon the number of the donor atoms. So on the basis of that, we have classified them as either unidentate or monodentate ligand, then didentate or bidentate ligands. Okay. So today we do the hard one. Polydentate ligands. That is, these ligands have more than 2 donor atoms. So these ligands have more than 2 donor atoms and binds to central metal atom or ions, ion simultaneously. Okay, now tardentate or tridentate. Yes. It is they bind with 3 atoms. Okay. These examples are not given in your book, but you should know for your entrance. This. Lone pair. This is a neutral ligand. Okay. See, when it was like this, we call it ethylene diamine. Okay. Here we are going to call we call it diethylene triamine. See, there are 2 ethylene groups are there. And how many NH2? 3. So it's called diethylene triamine. In abbreviation form, we write as DIEN. Okay. So if this is the metal atom, it will bind to. Now, I forgot the numbering. Maybe it is 3 only. I don't know. So now we call it tetradentate ligand. Example. shape is the metal, it binds through. This is called triethylamine tetramine. Triethylene tetramine. Tetradentate ligand is there in our biological system. Okay. So I'll just draw its skeleton. This is not required, but for your entrance exam. If you wish, you can draw it. Otherwise, you need not. The molecule looks very beautiful. See, nature is the great architect. This is the one. Okay. This is called porphyrin. See, when you have here iron, when you have iron here, we call this to be hemoglobin. And when you have magnesium, magnesium, we call it chlorophyll. See, this is a tetradentate ligand. আমি মহিলা অলরেডি চেক করে আছে সব তো দেরি হয়েছে ক্লাস শুরু করছি প্রায় 12-13 মিনিট পরে ভালো
Sir,
yes
where is mg?
hmm
So where is mg?
magnesium cool
So where is it in that?
where if iron is in the center this compound is called hemoglobin and if you have magnesium then this molecule is called chlorophyll. So you can say this is the most abundant tetradentate ligand in the nature, and it is the nature is making it. Should I rub it?
Yes.
Hello, all of you have done.
So done.
Okay. So this is only for your general knowledge. Okay. Now, if you have 5 donor atom, then we call them as pentadentate. Pentadentate ligand. Okay. So I'm doing this one now. See how many bonding sites are there. This is 1. This is 2. This is 3. This is O-4. And this is 5. Okay, this is called ethylene diamine triacetate. In short form, we write EDTA. 3 minus, see, minus 1, 2. So here you think it is like this. See here. So these are the bonding sites. So if the metal comes, it will bind metal like this. Now the last one which I have writing is extremely important. They will not ask you to draw. This is called hexadentate ligand. Okay. See this one. This is called ethylene diamine tetraacetate. We call it EDTA 4 minus. Is a very famous hexadentate ligand. With this, we determine the hardness of water because it forms complex with calcium and magnesium. And you know, the presence of calcium and magnesium ion in the water makes the water hard. EDTF4-. This is important for your exam, not the structure, name. So this one is important for your exam because even in multiple choice question also they will give you this example. Which one of the following is a hexadentic ligand? So they will give you name. They will give you EDTA3 minus, EDTA4 minus. Please remember EDTA4 minus is hexadentic. Okay. So now we'll go for a very special class of ligand. It's called ambidentate ligand. Ambidentate ligand. We have done this one in organic also. Okay. These are monodentate ligands which coordinate with central metal atoms or ions through more than one atom. Example. Okay. Is cyanide. See here. It can either bind to carbon or to nitrogen. That is, it can be this. So you get here cyanide. Or it can bind through nitrogen. Iso. Okay. Then thiocyanide. S C N. See, it can bind through sulfur, it can bind through nitrogen. So you will get here now. We call this compound as thiocyaneto. Or it can bind through sulfur. We call them as isothiocyanato. Okay, C. Nitrite. It is see, it can bind through nitrogen, it can bind through oxygen. it may bind through nitrogen. So we'll call it we call them as nitro. If it binds through oxygen, we write like this, ONO. We call it nitrate. Okay, now we'll go for coordination number, or also known as the ligands. It is the total number of monodentate ligands bonded to the central metal atom or ions through sigma bond. Okay, no. If any ligand binds with pi bonds, then it is ignored. That is, if anyone binds to pi bond, we will not consider it in the calculation of coordination number. Okay. So let us see here. Say I have taken here NH3,4. Say it is this. Here, ammonia is bonded to copper to 4 sigma bonds. So that coordination number is is 4. Suppose I have taken here FeCN6. T minus. It is FeCN. See, this is this. Here cyanide is bonded. Cyanide and Ni. This one. Here coordination number is 6. Yeah. Okay. Now suppose I have taken here ruthenium Cl2 CH2 CH2. It is plus. So it is Ru Cl Cl Cl, and this is ethene molecule. Okay, here it is being bonded to pi bond. Okay, so here coordination number is 1, 2, 3. We will not count this. So pi bond is not considered. This is for your entrance. Very difficult to remove. Now we will have coordination sphere. You know what is coordination sphere? It is nothing but the bracket that we put now, that is called coordination sphere. Within that, that is the central metal atom or ion and the ligands attached to it are enclosed in a square bracket and is collectively called as coordination sphere. Okay, say this is the what coordination sphere. Say it is this PTCl6 2 minus. This is the coordination sphere. Okay. Then we go for coordination polyhedron. Coordination polyhedron is nothing but the structure. Coordination polyhedron. The coordination arrangement of the ligand atom which are directly attached to the central metal atom or ion. Defines a coordination polyhedron. About the central metal. Okay, so it can be, say, let me take here PTCl4 2 plus. Okay, so what will be the structure here? Platinum gives maximum square planar complexes. This. So this is this is square planar. So I have taken here NiCl4 2 plus. Sorry, 2 minus. 2 minus. In this case, you'll find no. Sorry. NiCN4 minus. So CR4 2 minus. So it will be NiCN CN. No, this structure I have done wrong. Very now the board is not getting clean. Okay, see here. CO. Nickel tetracarbonate. This is neutral. So I write here now Ni, CO, 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 CO. This is a polyhedron. This is tetrahedron. Tetrahedron. The ink has just now I filled also ink. What happened? I don't know. Tetrahedron. Okay. This is 4 dear. 4. Now suppose I have taken this. Iron pentacarbonate. In this case, Fe, CO, 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 CO. Now you know the structure. What is this? This is trigonal bipyramidal. Trigonal bipyramidal. Okay. Now suppose I have taken here CO EN3. EN means ethylene diamine. So it is, I've given you intentionally so that you should know the structure so nice and beautiful.
মাছ রেখেছি মাছ করবা আমি মিষ্টি কুমড়া ভাজা মিষ্টি কুমড়া দেখেছেন ভাজা টুকরো করে পেঁয়াজ দিয়ে ভাজা
See, this is octahedral. হ্যাঁ ওইটাই ধরুন क्या होगा तो सफाई नहीं होता है Okay, now we'll go for oxidation number. Oxidation number of the central metal atom, so you know how to find out. We'll remove all the ligands of central metal atom. So it is defined as the charge the central metal atom would carry if all the ligands are removed with the bonding electron pair. So this is the way we calculate. So you know how to do it. But why should I tell? What should I tell? Say, let us take the example of NiCl4 2 minus. So how to do? So I write here A, I want to find nickel. 4B is equal to -2. A plus 4 minus 1 minus 2. A minus 4 minus 2. So A 4 minus 2. So A is equal to plus 2. This is we calculate. So let us go for Fe CN6 3 minus. See, we are not going to find for carbon and nitrogen. We know cyanide is a anionic ligand. Cyanide is -1. So here what we write now here 6 this. So 6 minus 1 minus 2. So minus 6 minus 6. See? Six minus 3. So A is equal to plus 3. So this is the way we calculate. Now, see it is FeCO5. Okay. See, this is a neutral compound. No charge is there. So I'll write now here. A plus 5B is equal to 0. Please remember, carbon monoxide is a neutral molecule. So A 5 into 0, 0. So therefore, A is equal to 0.
Done, sir. So, one son, your Christmas marketing is over. We haven't even gone, sir.
Oh. So who has finished Christmas marketing? What? Ajalia, finished? 50. Sorry. My handwriting is becoming worse day by day. Homoleptic complex. See, the complex in which only one type of ligand is used. This is called homoleptic. Complexes in which the central metal atom or ion is bound to only one kind of ligands. are called homoliptic complexes. So many examples I have written till now. So you also can write. And then why every time why do you write metal, atom or ion? So let us write this one. You know the oxidation number. So I have taken here CO NH3 3 minus. See here, oxidation state of cobalt is +3 because ammonia is a neutral molecule. So it is a metal ion. Okay. Fe CN6 3 minus. Just now I've shown you it is Fe3 plus. Okay. Then NiCO4. Here you know oxidation state of nickel is 0 means what? It's metal atom. It's not an ion. So these are the examples, etc. Then heteroliptic complexes. So what you have to write there here? Complexes in which central metal atom or ion is bound to more than one type of So I'll write down here. Heteroliptic complexes. So here you write bound to more than one kind of ligands are called heteroliptic complexes. ठीक है, तो इधर मैं ऐसा कर देगा. It is Cl2 NH4. You are related plus because chloride is -1. Okay. Yes, 3 minus. Is neutral. I've given.
Done, sir.
Now we have come to the nomenclature. Now once and you know how to name a compound.
No, sir.
Very good. nomenclature of coordination component. There are a lot of rules are there, huh? But you know, it is a matter of only few seconds you can. And when I write down, it's very long, but it is very simple. So now you can classify them into two categories. How to write the name and how to write the formula. So let us go for writing formula. Of coordination entities. Acha. Hello, Drishti, you know how to write the name and formula? Drishti? Hello? I think she is there or not. I'm doubtful.
Not here, sir.
Not here, na? Aditi, you know how to write the formula and name? Aditi is also not there.
Present, sir.
Present. So, mat diya nai kyo? Mone mone ase kyo?
Sir, কৰিছিলো স্কুলত।
Oh, সঁচাকৈ তাহানি নহানি লৰালি কালত কৰিছিলি নহয় এতিয়া পাহৰিলি বুঢ়া হলি see here I write only the short form you read from your book rules see whenever S because it's an inorganic compound first you have to write the formula of cation followed by Ni cation is all right symbol of cation is written followed by Ni. Finish. Now the cation may be complex or anion may be complex. Irrespective whether these are simple. Simple means what? Potassium, sodium like this, or chloride, bromide, iodide like this. Simple or complex. Second, now we are going for coordination entity. In coordination entity, first, the symbol of metal atom or ion is written. Okay. Followed by the symbols of ligands in alphabetical order, irrespective of their nature. Means what? First I'll write the symbol of the metal, then I'll write down the symbol of the ligand, whether they are neutral or positive or negative will not bother. All right. So here I'm writing in this way. So it is cobalt. Okay. Then I have says here I have taken here Cl. Say it is containing 3 types of ligand: chloride, bromide, ammonia. So I'll write B comes before Cl. So I'll write now here Br. Say there are 2 are there. So I'll write 2 Cl 2. Then ammonia 2. All right. I'll write like this. See, first I've written metal. Then these are in alphabetical order. So this is metal. And these are in alphabetical order. Alphabetical order. See here. In that case, though ammonia we spell it as AMMNIA, but symbol of ammonia is NH3. So I'll only consider the first alphabet of the symbol. First alphabet of symbol. Okay, take the example of water. Spelling starts with W. Symbol starts with H2O. So in that case, suppose it is like this. CO, Cl2, H2O, NH3. Okay? This. See here. C comes before H. H comes before N. So in this case, I will not go by the spelling. I will go by the first alphabet of the formula that we follow. Here, first alphabet of the water is H. First alphabet of the ammonia is A. I'll write like this. Samjha? Hello?
Yes, sir.
Ananya. Ananya, though I have not called her name for last 2-3 months. Ananya is there. Hello. Missing. Estella is there. Estella. What about? Are you having exam or what? Then I'll write here. See. Polydentate. Polydentate ligands are also alphabetically arranged. Generally, polydentate ligands we polydentate alphabetically arranged. And if they are represented as abbreviation, then these are also alphabetically L. And R written within parenthesis. See here. Say example. See this. This is called oxalate. Okay? Oxalate. So, how they are written? They are written as C2O4 or as ox. So, if you write it, it has to be within bracket. Say this one. You know what is this? This is called ethane, 1,2-diamine. Its abbreviated form is EN. So when you go, we'll see. First alphabet is E. Okay.
Excuse me, sir.
Yes, yes.
Sir, we have next class at 9.
9, na?
Yes, sir.
What class?